Hey, this is Riley, and I'm going to be presenting my course project 2. This is my general layout of my hospital design. You can pause it and take a better look if you want to, but basically each of these colored rectangles represents like a physical area in the hospital, and these little clusters are going to be associated departments. I want to start my explanation of my whole network here in my central server room. First things first, I just want to go over my encryption real quick for my data, both in transit and at rest, at rest. So for data in transit, I plan to implement the secure sockets layer, as we did in course project 1 with MTLS and TLS 1.2 and 1.3, all that jazz, just to kind of keep that in-transit data secure and encrypted, unreadable to anybody that may be doing a man-in-the-middle attack or something like that. For data at rest, I've got two different encryption schemes. I've got full disk encryption, which would be done by a software like BitLocker. This just takes all contents on a disk and encrypts them, treats it all as raw bytes, just encrypts it all. And then we also have database encryption, AES 256, which isn't just database encryption, but it is used in database encryption pretty commonly. And this is used in conjunction with FDE encryption, but it's a little bit different in that it can distinguish between certain database concepts like tables, queries, or even like user roles. It will automatically unencrypt or keep encrypted based on your user role, right? So using both of these together in conjunction is pretty common practice for enterprise networks, especially something that's regulated by HIPAA, right? Hence the two layers of encryption on data at rest. And then on top of this encryption that you would find, we've got medical records databases that of course need that encryption, and you've got associated backup servers, which would then again need that encryption. Backup servers that would both coordinate and store those backups, just to prevent data loss should maybe the power go out or something like that. We've also got like a logging server that would hold audit trail data, and I plan for audit trails to be implemented by software on each networked computer. It would send any patient record accesses or any patient chart data changes to the server and log them there. And I think that's all I want to touch on my server site for now. I want to start going over my firewall setup. I've got a next generation firewall and a web application firewall in my firewall layer. And this is common throughout my whole system design. Anytime I have a firewall layer, I have one of each of these types here. The next gen firewall goes over application layer data, as opposed to older models that went over like TCP, UDP ports and filtered content out that way. This one can look at application layer data to make those decisions. Then we have web application firewalls that can detect like SQL injections. This pertains mainly to web-based traffic, like HTTP and HTTPS. And these are commonly used in conjunction just because they both look at different threads. They look at different items to make routing decisions, right? Should we block it or should we let it through? And you see I have a firewall layer here. We call this the perimeter firewall that stands between my public-facing core router and my internet, which is represented by this router. So I've got my outward-facing perimeter firewall. I've got my DNZ firewall. That's blocking off my server site here, my precious server site. And I also had in mind a special configuration for my perimeter firewalls, which would allow, like I think it's a VPN concentrator was the term, where if somebody from outside the hospital tries to connect to the hospital, they can get like a secure tunnel, get assigned a hospital IP, and be able to access the network. And that would come in handy for something like a doctor logging into a portal after hours, or maybe a patient logging into their hospital portal to access their records, something like that. Create like a VPN tunnel, secure tunnel into the hospital network, which is a special configuration you can do on some next-gen firewalls. So that was just a little consideration I had in mind there. But we also have, if we go into this radiology module, we have internal firewalls as well at the head of each department. Once again, a next-gen and a WAF and series, just like that. I think that just about covers all my firewall knowledge. But since we're here in this radiology module, I might as well point out that I am using role-based access control lists, and in each of my modules I kind of have these labels that spell out user groups that would require specific permissions. I've got these here, obviously, the radiology technologists and etc. And then I've got something a little bit different here in my admin office, like directors, managers, executives. So those labels there kind of spell out my user groups, and they're sorted both by department and by role, and that's just to give that extra little bit of specificity, so we're definitely not giving out more permissions than we need to, right? But something that kind of goes hand in hand with these access, control lists is my VLANs and my network segmentation. It all is just meant to kind of direct traffic, allow accesses. So the way I had my network segmented was I have both VLANs and subnets in kind of a one-to-one fashion, which is pretty standard for most enterprise networks. You can see here we've got a VLAN 4 inside of this rectangle, and here we've got VLAN 5 in this rectangle. And a special consideration I made was that each medical device would be on its own VLAN and its own subnet, which is actually, I think, specified in HIPAA regulations. But the way that this would be configured on the network is we would have, these access layer switches and all these access layer devices grouped into these VLANs. The VLANs would be configured on these also, these layer 2 distribution servers. Layer 2 as in they deal with MAC addresses to route packets, as MAC addresses are a layer 2 concept, right? And then you would have all these VLANs configured on this layer 2, and then you would have this layer 2 distribution server trunked to a layer 3 core switch back here in my central server room. And this would be necessary, like this layer 3 versus layer 2 distinction is pretty necessary because here I would have my subnetting, right? Because IP addresses are a level 3 or a layer 3 concept. So we would have subnetting organized on my layer 3 switch, and we would have VLANs organized on layer 2 switches, organized beneath these core layer 3 switches. But the thing that links them all together is called a switched virtual interface. So you can kind of connect a subnet range to a VLAN on a layer 3 switch to allow for inter-VLAN and inter-subnet routing, right? And like an example of this would be like we have VLAN 1 with this subnet. So this core switch would have this gateway address, but not only would it have that one gateway address, it would have a single gateway address for each VLAN in each subnet that we have mapped together in that SVI. So that's why we've got 26 VLANs, and our core switches would have 26 addresses, 26 gateway addresses apiece. And you can pause if you want, make sure my conversions or my gateway address conversions are correct. But that's just kind of the major kind of organization there. We've got layer 2 access into layer 2 distribution, trunked to a layer 3 core switch that then brings VLANs and subnets together to create that segmentation, right? So, yeah, I mean, I think that's all I can say for this. It's really important to kind of note that each SVI connection that maps a subnet to a VLAN gives the switch its own kind of gateway address just for that inter-VLAN routing capabilities, right? And something else I did here was I had 2 core switches, so some gateway redundancy actually, and what this means is that all of these addresses here, they wouldn't be shared amongst these 2 switches. They'd be allocated to one switch, and then we would have kind of a fallback switch should anything happen. I think Cisco has a protocol called, I think it's like CSRP or HS, I think it's HSRP, that would actually, that protocol would actually kick in, should the core switch fail. It would swap to the other ones, swap the gateway addresses, and you'd still be up and running, right? But I guess that's all for network segmentation. It's it's a lot, but if you have all of this in front of you, it's super simple to kind of pause, think about it. But moving on, I also have that secure wireless implementation, and I've done that through, if we look back at these access layer devices, I've got access points, wireless access points for doctors and other staff to use. And those would be password protected, right? We would use EAP authentication, which is why I actually did have this other authentication server just for that EAP authentication, right? So a password protected EAP authentication, secure wireless, in these kind of already existing VLANs for doctors to use, right? But along with that, of course, I had to have a guest wireless, and the way that I kind of wired that into the rest of the existing network was I just ran, it's going to be this connection right here. I ran one gigabit connection over to this third core switch, once again, comes in through here. A gigabit connection comes in through here, through these firewalls, exists right here. Then I have another kind of layout of the hospital, but you can see how that guest Wi-Fi switch, once again, has a bunch of access points wired up to it all throughout the hospital. And it's all on its own separate VLAN. It's all on its separate subnet, just for, once again, that manageability, that security for that performance. But more to the point of security is I have it isolated on its own VLAN and its own subnet, but I also have these firewalls that can actually be configured to block all outbound traffic that is not going, out to the internet, right? If somebody on the guest Wi-Fi is trying to access the medical records or the logging server IP, we can just have those firewalls block it. Or we can have even these DNZ firewalls configured as like a double fallback. And that's just all to kind of isolate that unsecured, non-password protected guest Wi-Fi, right? And honestly, I think that just about does it. I've gone over the encryption, the audit trails. We've got encryption, we've got audit trails, we've got backups, we've got access-based control lists, here in these labels in each of the departmental modules. We've got network segmentation with these VLANs, with these subnets configured throughout layer 2 and layer 3 switches. That's what it was called. It was called hierarchical IP addressing, right? So you've got layer 2, into a layer 3, along with an SVI to kind of tie subnets and VLANs together. Then you've got both the secure and the non-secure guest wireless networks. And another important point that I almost forgot to mention actually was that these networks would need two different SSIDs. If otherwise it's basically not really separated, right? Like you would need a unique SSID or a unique Wi-Fi name for the guest AP so that they connect to the guest AP, and you would need a unique SSID for the secure wireless just to make sure they connect to the secure wireless network. And that, if they're in like the waiting room connected to the guest Wi-Fi and they walk to the radiology, how are you going to stop their device from auto connecting to the secure access point in here? Well, that's because it'll be a different SSID, so their device will know not to try to connect to the secure access points, right? It'll keep them separated effectively into a guest and a secure network. But I do think that just about does it. Thank you very much.